Hey everyone, today I'm going to be talking to you about alternating current and the sine wave. Alternating current is a current that reverses the direction of its polarity over time, and this is done using an alternating waveform. So this could be like a triangle wave or like a square wave, but today I'm just going to talk to you about the sine wave. So this is the general form of a sine wave, and the best thing about this form is that we can extract a lot of information about the wave and what it looks like. Y is our current or our voltage as a function of time. So as our time changes, our value for Y is going to change as well. A is the amplitude of the sine wave, which is essentially the height of the wave, or the maximum value the wave can reach in either direction. The F in the brackets is the frequency of the wave, and this tells us how many waves passes through a point within 1 second. And using this, we can calculate the period, which is the time it takes for a wave to complete a full cycle. This is just done by taking the reciprocal of the frequency. And theta is the phase of the wave, and the phase of the wave is just a measure of how the waveform is shifted left to right with respect to time. Now I want to show you a video in relation to how the angle of the sine wave is produced. If it wants to play. The angle made by the radius connected to the x-axis forms a right triangle. So as the radius rotates around the origin, the sine wave produces the relationship between the degrees of the central angle, which is the x-axis, and the sine ratio of that angle, which is the y-axis. Another important aspect of the sine wave, especially in a practical sense, is the RMS or root mean square value. The RMS value is the equivalent of a steady DC value, which gives the same effect. This is calculated by dividing the peak value, or the amplitude, by the square root of 2. And there's a full derivation of this, but I don't have enough time to talk about it. Now onto a quick example. So for this waveform, v of t equals 170 sine of 2 pi 60 t. We can see it's in the general form of a sine wave, so we can pull it apart pretty easily. As you can see, our amplitude is going to be 170 volts, and our frequency is going to be 60 hertz. And when we graph this, the maximum value is going to be 170, and it's going to go through 60 waves before the x-axis reads 1 second. And this is what it looks like. As you can see, it goes up to a positive 170 and back down to negative 170, which completes a full cycle in about 0.017 seconds, which is the period. We can also get the RMS value for this wave by dividing the amplitude by 170 by root 2, which gives approximately 120 volts. What this is saying is that this alternating current was connected to a light bulb or something. You could have the same power dissipation as 120 volt DC in the same system. So that's pretty much it. Thanks for watching. Yeah, use it how you want to.